Hello class, today we're gonna learn about the language of algebra. So today you get to be the translators, and what you're going to be translating is from the English language to the math language. So together we're going to go over what it is you need to know, a few important keywords, and we'll do some exercises together, and you'll get to do a few exercises on your own. The first thing we're going to talk about today are just the most common keywords that you need to know based on the most common math operations. The four most popular operations, which are addition, subtraction, multiplication, and the last one is, if you said division, you said the right thing. Alright, so those are the four most popular math operations, and the thing is, they're not always going to be listed to you like this. You're not going to always be told to add or subtract. There are sometimes important keywords that you have to look for. In your book, there's a table. On that table, there are important keywords that we need to know. Well, you'll notice in the addition, few keywords that are showing up there are sum, plus, added to. In the subtraction, we want to look for difference, minus, subtract, less than. For multiplication, there's product, times, multiply, etc. And for division, you want to look for words such as quotient, divide, per. Now, there are four keywords that I want you to always pay close attention to, and those four keywords kind of fall under the same umbrella. They're part of the same family, and they are words that represent those four operations, but the ones that I'm talking about in particular are the words sum, because sum represents addition. Subtraction would be the word difference. For multiplication, you would look for the word product. And the last one, for division, you would look for the word quotient. Now, those are four very popular keywords that we have to pay close attention to when we see them. But what I'd like you to do is to start getting in the habit of doing this. When you see the word sum, don't just put a plus sign. My recommendation for you is to put parentheses and inside put a plus sign. And I'll show you why when we start to do a few exercises together. The word difference, put parentheses and a minus sign. For the word product, put also parentheses, and let's do the dot to represent the product. All right, and the last one for the quotient, we're going to go ahead and put parentheses, and we will use the division bar in this case to represent the quotient. So whatever goes on top of it, that would be our numerator, and whatever's on the bottom, that would be the denominator. All right, so now let's go ahead and do a few exercises together. And what I'd like you to do is take a moment to read the first statement and try to spot out the keywords. You can go ahead and underline them. So we have a number increased by 5. So a number, if we don't know what it is, what do we use to represent? If you said X, you said the right thing. So the number, we don't know what it is, so we're going to put an X. Increased by, that's also one of our keywords that represents addition. So increased by means we're going to be adding. And 5, of course, represents itself, which represents the number 5. So if we are to pretty much write that as an expression, that would be a number, our X, plus, that represents increased by, and the number 5. So the answer would be X plus 5. All right, now let's take a look at the second statement. We have twice a number minus 4. So once again, if we highlight the keywords, we've got twice. And twice, which means, if you said 2 times, you got the right thing. Twice is a different way of saying 2 times something. So that would be 2 times a number, there goes again, and that represents our unknown, so that's our x, minus is our subtraction, and 4 again is the number 4. So if we want to write that as a final expression, this would read as 2 times a number. So 2 times a number, that's our 2x minus 4. So our final expression is 2x minus 4. Now the last one, we have 7. Of course, that's the number 7. The keyword here is divided by a number. Again, our number is the unknown, so that's the x. So now to translate all of this, we can write it as 7 divided by x. But we can also write it as a fraction. We can use it, the division bar, to represent the division. So you can leave it like this, or you might want to do it as a division bar, and that would be 7 divided by the number. So it would be 7 over x. You're more likely to see it written as a fraction because that's more of the form that we tend to use to represent division. Now, there are a few things in math we have to watch out for when it comes to subtraction. Because as you know, subtraction is not commutative, so the order does matter. For example, if we do 3 minus 1, we get 2. But if we do 1 minus 3, then we're not going to get the same answer. We end up with a negative 2. So we have to watch out for those keywords that represent subtraction. So some of those words that I would like you to pay attention to are less than, subtracted from, and the last one is taken from. So those are what I'd like to say the popular words or our keywords that you have to watch out for, because when you see those 3 keywords, what's going to happen is we're going to have to write the expression backwards. Again, so watch out for them. Less than, subtracted from, taken from. So those will allow us to write the expression backwards. So with that in mind, we're going to go ahead and do a few more exercises together to see how we treat those keywords when they are written in an expression. All right, now let's go ahead and do a few exercises together. So the first one, we have 5 taken from a number. So again, if we notice here, the keyword is taken from. And taken from is one of those words that we had talked about earlier that we use to represent subtraction, but it's the one where when we see it, we have to construct the expression backwards. So for example, if I am to take something from you, okay, in order for me to do that, you have to have something first so that I could take something from you. Hopefully that made sense. So if I have 5 and we have a 5 that's taken from a number, don't you agree that we have to have the number first so that we can take the 5 from it? So with that in mind, even though we see 5 first, it has to go in the end because it's the 5 that's being taken from the number. So 5 taken from x. So the expression would be written as x minus 5. That's the answer for that one. Now the next one, we have a number less than 2. So once again, the number, as we mentioned earlier, represents our x. Less than is our keyword here that represents subtraction. So a number less than 2. I'll give you a few moments to write it down on your paper. All right, so now a number, that's our x. Less than is one of those keywords that we have to write backwards, 2. So the answer is 2 minus x. So that's how we translate a number less than 2. Alright, the next exercise. 5 less a number. Again, I'll give you a few moments for that one. Alright, here we notice the word less. So it's missing its than, right? But it really doesn't need it. So we have 5 less a number. In this case, if it's not less than, you don't have to write the expression backwards. So in this particular example, we'll start off with the 5. The less represents subtraction, so it'll be minus, and the number is our x. So the answer will be 5 minus x. So watch out for that. So if you have less, you will treat it differently than you will less than. So less than, we construct it backwards. Less, you would write it in the same way as you are reading the expression. Okay, we'll leave the challenging one till the end here. So again, I would like you to take a few moments to try that one on your own. 4 subtracted from twice a number. So look for the keywords. Subtracted from is one of them. We talked earlier about twice. We have the number that represents x, and the 4, which of course represents the number 4. So as we had mentioned, subtracted from is one of those keywords that we have to write backwards. Twice, meaning, if you said 2 times, good job. And the number is x. So 4 is what we would have to write last. So we are subtracting 4 from something. So 4 needs to go in the end. And what is it that we are subtracting it from? We are subtracting the 4 from twice a number. So as we had said earlier, twice means 2 times something. So that's 2 times x. So 4 is being subtracted from twice the number, but as we know, we don't need to show the multiplication because 2 times x is the same as 2x. So the final answer would be 2x minus 4. I listed 4 examples here on the board, and let's first underline the main keywords. Starting with the first one, the sum of 5 and a number. So here's one of our main keywords. The product of a number and 8. There's another keyword. Twice the difference of a number and 7. And the last one, twice the number decreased by 10. So those are pretty much our main keywords within each expression, even though there are a lot more keywords within each statement. But I want us to focus on those now for now. And if you mentioned earlier, if you remember earlier, I had mentioned that we have the words sum, product, difference, and quotient. I said those fall within the same family, under the same umbrella. And if you notice, when we use those keywords, what other word do you see that they all have in common in each of those statements? So we have here the sum of, okay, if you noticed of, that's good. But also, there's another word, and that's the word and. And. Because even when we try to use that word as that statement, we say the sum of this and that, the difference of this and that, the product of this and that. So the word and has to be used in that statement to have it grammatically correct. Let's just put it that way. But in our case, we are going to use that word to our advantage. And the way that works is that if you remember, I said when you see any of those keywords, the moment you read it, put parentheses and the operation symbol that goes with it. So the sum, let's go ahead and put right away, parentheses and plus. Now when we have the sum there, it's going to be of 2 things, this and that. So whatever we see before the word and goes before the plus sign. Whatever goes after the word and goes after the plus sign. So the sum of 5, so that's the 5, and represented by our sum, the addition, and the number is x. Now since there's nothing there, now you're free to remove the parentheses if you wish. So you can leave the answer as 5 plus x. And that's how that works. Right, now the next exercise, the product of a number and 8. So product, as we had mentioned before, is multiplication, so parentheses and the multiplication symbol. Now the word and is being represented by the multiplication symbol that we use. So whatever is before and goes before multiplication sign, and whatever is after and goes after it. So the product of a number, that's the x, and 8, so that's times 8. Now, we wouldn't want to leave it that way. It doesn't look nice, right? We can clean it up a little bit. So we can fix it up, and instead of saying x times 8, we can write that as 8x without the parentheses, and that would be our final answer for that one. Here's the next exercise. It says twice the difference of a number and 7. So go ahead and take a few moments to try to set this one up on your own. You can also pause if you want a longer time. So let's go ahead and try to work this one together. So twice, as we had said, means 2 times. The difference, that represents subtraction. The number is the unknown, and of course the 7 that represents itself. So here, that's where you're really going to appreciate the parentheses that I talked to you about. Because here we're saying 2 times the difference. So when we say twice, twice translates to 2 times. So you don't want to put 2 times and a minus sign. What you want to do is use the parentheses with the minus sign to represent the difference. So that's 2 times the difference, the entire difference. So that's how it reads. Twice the difference of 2 things. And those 2 things are the number and the 7. So that's how we translate this statement. So again, here you will need to leave the parentheses because there is something outside of it. But you wouldn't need to put the multiplication symbol, so you can write it as 2 parentheses x minus 7 and leave that as your final answer. Now the last one over here, it says twice the number decreased by 6. Here, are we, I know twicing is not a word, but are we doubling? Are we multiplying the whole difference, or are we only multiplying a part of it? Here it says twice the number. So it's not the entire difference, even though decreased by is subtraction. It's twice the number, so that's 2 times only the x. And then this is being decreased by the number 6. So that's why when you see those words that I had mentioned earlier, sum, product, difference, quotient, get into the habit of putting the parentheses there. If you don't need it in the end, you simply take it out. Because you'll see how you can easily make a mistake if you were supposed to put it and you didn't. Here, it's decreased by is not one of those popular keywords that we had mentioned. So here we're only doubling the number, but not the 6. So we can leave it as 2x minus 6, and that would be the final answer for this expression. The last thing we're going to look at is how to set up equations. So we've already learned the important keywords when it comes to setting up expressions, but there's just one last part that we need to look at, which is how to set up equations. So we want to refer to this table to look for the keywords that represent the equal sign, because as you know, in the equation, an equal sign is definitely necessary. So those are important keywords that when we see them in the statement, they translate to the equal sign as we are doing our translation. All right, now let's go ahead and do a few more exercises together and focusing on setting up equations. So with the first example that I have up here, we have 3 times a number added to 4 is 16. So out of those words in the statement, which word do you think represents the equal sign? And if you answered the word is, you are absolutely correct. So what we can do is set up the equal sign, and then this way we know that anything that we see before is going to go to the left of it, and when anything that goes after it goes to the right of it. Now, definitely the right side is much shorter, so we can go ahead and finish that one off. So is 16 means equals 16. Now let's focus on the left side of the equal sign and treat that just as a normal expression as we have done in the previous exercises. So 3 times a number added to 4. 3 times a number, that would be our 3x, so that's 3 times x, added to 4. Again, added would be our addition sign, so that's the plus. 3x plus 4 is 16. Now, we're not going to solve any of those equations. We're simply going to be setting them up. If we are to solve it, then we would solve it following the same directions as you would when you have to solve any linear equation. But now we're just going to set them up. The next exercise is the sum of a -5 and a number is equal to 8. So if you want to pause this a bit longer to give you a few moments to set it up on your own, you may go ahead and do so. So let's go ahead and do it together. The sum, watch out for that word, so the sum, this is our sum, of 2 things, right? Something and something. And remember the plus sign, we're going to treat that as our and. So the sum of what? -5 and the number. So that's -5 plus x is equal to, this right here represents the equal sign. So we could have started off with the equal sign, or we could have just started with it left to right and translating as we went along. So you've got a couple of options on how you want to go about setting up your equations, or I should say translating your equations. So is equal to 8. Now once again, because there's nothing outside of your parentheses, if you want to go ahead and take them out, feel free to do so. So the sum of 2 things, the -5 and the x, is equal to, that's our equal sign, the number 8. Good? Now, the last exercise is twice a number less than 4 gives us 10. So if you want to pause, go ahead and do so once again to try to set it up on your own. But we are going to go ahead and work on it. So twice, 2 times, as we had mentioned before, a number, that's our unknown, that's our x, less than. What do you remember about less than? If you said that's one of the words we have to write backwards, the expression backwards, then you're absolutely correct. Gives us, or you could just focus on gives, that's where the equal sign is going to be replaced. So if we want to start with the gives part, or the gives us part, we can do that. Gives us what? 10. Then we can put the 10 on the right side and get that over with. And now focus on the first part of our equation, which is twice a number less than 4. So we can start backwards. So twice a number, that's 2x. It's 2 times x is twice a number less than 4. So the final answer will be 4 minus 2x equals 10. And that's how we can, that's what we get as our final equation for each of those statements. Alright, now that wraps up our session on translations. So now we are able to translate expressions, we are able to translate equations. So make sure that you get very familiar with those keywords that we talked about, and also the other keywords that are mentioned in the tables that were introduced to you in this video. And there's a link for it, for the handout that you need. Make sure you use it to take the notes as you are watching the video, and also there are exercises on it that you need to make sure that you complete to give you more practice, and this way you can become the best translator from the English to math language. So thank you so much for watching the video.